I have something fun today. We are going to talk about the upper and lower bounds of, say, measurements. It has something to do with rounding and significant figures. It'll be fun. Let's say I have a pencil and I measure my pencil. I'm not going to measure it too carefully because I'm only going to measure to the nearest centimeter. I measure it kind of roughly, and I tell you that the length of my pencil is 12 centimeters. Now that 12 centimeters, really, if we were more careful in measuring, maybe like if we used a ruler that also showed millimeters, maybe we would get 12.2 centimeters. But because I said I was only going to measure to the nearest centimeters, I will write 12. Now, if we wanted to say something about the more precise actual, like the real actual length of this pencil, we could state the lower bound of the length. The lower bound, like what this means, what is the, if this pencil is 12 centimeters rounded to the nearest centimeter, then what is the lowest possible actual length of this pencil? That's what lower bound means. And then we could say, what is the upper bound of the length of this pencil? If it's 12 centimeters to the nearest centimeter, of course, it could be 12.3, 12.4. We're going to describe the upper and the lower bound of the length of this pencil, and that's going to tell us a lot more about its actual measurement. If we were to draw a number line, we would say 12 is right here, right? 1, 2, 3, 4, 5. These are millimeters. 6, 7, 8, 9, 10. This would be 13 centimeters, right? And if we 3, 4, 5, 6, 7, 8, 9, 10, we're not going to care that they're not, yeah, the distances are kind of weird. But if I tell you my pencil is 12 centimeters to the nearest centimeter, and I'm going to color in the actual lengths that this pencil could have. If this is 12.1, my pencil could also be 12.1 centimeters, right? It could also be 12.2, 12.3. It'd be nice if I'd used a lighter color. Now, where is the point on this number line where I would say, oh, I have to round up and make it 13 centimeters? That point is actually 1, 2, 3, 4, 5, right here. From 12.5 on, I would have to round up, right? So my highest possible real value for the length of this pencil could be 12.5, right? And how low could my actual value go? It could be 11.9, right? That rounds up to 12. 11.8 also rounds up to 12. 11.7, 11.6, 11.5. 11.5 also rounds up to 12. But anything even the smallest bit below 11.5 rounds down to 11, right? So this is the range of values that my real life, actual, most precise length of my pencil could have are. And so the lower bound of this measurement would be this here, 11.5 centimeters. And the upper bound of my measurement would be 12.5 centimeters. right? And so we could also say the range of the length of my pencil could be described by this. It's between length. It is between 11.5 and 12.5. And if we want to be super exact, we would have to say it is bigger or equal to 11.5 because 11.5 is included, right? 11.5 would still round up to 12. It is smaller than 12.5, not including 12.5, because starting at 12.5 we would actually round up. That's why I don't say smaller than or equal to. I only say smaller than because 12.5 is not included. I say this now, but all our calculations from now on are going to be with this upper bound as an actual value for the length. So just realize it's actually not included if you were going to be super exact. Let's do another example. Say I have an eraser and it has a width, it's a big eraser, of 3.2 centimeters, and it has a length of 5.6 centimeters. Now, if I were to ask you, what is the lower bound of the area of my eraser, the surface of my eraser? What is the lower bound of the area and what is the upper bound of my area? First, I would have to write down what the lower bound of the width is. I'm going to write width lower bound. The lower bound of my width is 3.15 centimeters, right? If it goes below 3.15, it would round down to 3.1. Starting at 3.15 and up, it rounds up to 3.2. The width's upper bound would be 3.25. Right? That's the width. The length also has a lower bound, which is 5.55 centimeters. The upper bound of the length is 5.65. See how my upper bounds and lower bounds have one more decimal place than our rounded values. That's always true here as well. So the area, the lower bound area, the lower bound of the area, how do we get the smallest area of this eraser? That would be if the width was at its lowest and the length was at its lowest. So we're going to take the lower bound of the width and the lower bound of the length, which is 3.15 times 5.55. We multiply the numbers to get the area, right? And this would be 17.4825 centimeters squared. That is the lower bound. So that is the lowest possible area, surface area of the eraser. The upper bound of the area how would this surface area of this eraser be the biggest if we had the biggest possible width and the biggest possible length? So the upper bound of both of these. Upper bound of the width is 3.25, upper bound of the length is 5.65, and that gives an area of 18.3625 square centimeters. So that is the upper bound of the area of the surface of my eraser. Okay, and you know, there's a difference between the two, obviously. Let's make it a little more abstract and just say we measure two things, thing A and thing B. Let's say A is 2 centimeters and B is 3 centimeters. And we want to know the upper and lower bounds of A plus B, A minus B, A times B, and A divided by B. Okay, so we want to know the upper and lower bounds of these calculations, right? The product, the difference, etc. First, we want to write down what the upper and lower bounds of our A and B are, right? Because we're going to use those a lot. The lower bound of A is 1.5, right? The upper bound of A is 2.5 centimeters. Whoops. The lower bound of B, B lower bound, is 2.5 centimeters. B's upper bound goes up as far as 3.5 centimeters. Cool thing here is that A's upper bound is 2.5 and B's lower bound is 2.5. So, you know, they could even have the same size in real life. A and B could. Because here these numbers are exact to the centimeter, right? So this in real life could be as high as 2.5. This in real life could be as low as 2.5. So I think that's funny that they could be the same. Anyway, A plus B. We add A and B. What is the lower bound of this calculation? Like, how could we get the lowest answer to this calculation? Sorry, I'm thinking. Well, the lowest we would get if A was the lowest and B was the lowest, right? Because we're adding them. So A's lower bound plus B's lower bound, right? That would give us the lowest number. Oops, I should write lower, lower, low. How do we get the lowest? A's lower bound is 1.5 plus B's lower bound is 2.5. So that would give us 4 centimeters. Now the upper bound of this calculation, how do we get the highest A plus B? That would be if A was at its highest and B was at its highest. A upper bound plus B's upper bound. That would be 2.5 plus 3.5, 2.5 plus 3.5, and that is 6 centimeters, right? This is more interesting. A minus B. How do we get the lowest value for this, and how do we get the highest? The lower bound for A minus B. How do we get the lowest number here? If we start with a low number and subtract as much as we can, that would give us the lowest number, right? So we start with the highest, with the lowest possible value, lower bound for A, and we subtract as much as we can. So the upper bound for B, that would give us the lowest answer, right? A's lower bound, Oh, I messed up. I wanted to do, because B is 3 and A. Oh, sorry. I wanted to do B minus A. B minus A. And here I want to do B divided by A, just because it's easier. Sorry. So still, we want to start with B's lower bound then and subtract A's upper bound. Oh, sorry. I'm not going to start over. B's lower bound is 2.5. A's upper bound is 2.5. Oh my goodness. We would be left with nothing. Well, that seems kind of low, so that sounds good. The upper bound of B minus A, how do we get the highest number for B minus A? Well, you may want to start out with a big number, the upper bound of B, and subtract as little as possible to have as much left as you possibly can. So B's upper bound is 3.5, and we subtract as little as we can A's lower bound, which is 1.5. And this is 2. Right? And we're talking centimeters, of course. So really, you have to think about what am I subtracting? What do I want to subtract to get the highest possible answer or the lowest possible answer? A times B, that makes me think of the eraser surface area question. To get the lowest possible product of the two numbers, we want to just have two low numbers, right? So A's lower bound times B's lower bound. That equals 1.5 times 2.5, and that equals 3.75, right? To get the upper bound of the product of A and B, how to get the highest product, we want both numbers to be big. So both numbers upper bound, which would be 2.5 times 3.5. How much is that? We need our calculator, or we take a minute. It's 8.75. The difference between these two, between the lower bound of the product and the upper bound of the product, the difference is 5. So that's pretty, makes a difference. If we divide B by A, our answers could be as low as what? And as high as what? Let's see. To get the lowest possible answer for this, you want to, I think of lollipops. You want to, how do I get the least lollipops? Is if we start out with only a few lollipops and we divide them by a lot of people, right? So B's lower bound, not very many lollipops, and we divide it by as many people as possible, which would be 2.5 divided by A's upper bound is 2.5. We each get one lollipop. Cool. How do we get as many lollipops as possible? Well, we start out with a lot of lollipops, upper bound, and divide them by as few people as we possibly can. So the lower bound of A, which is 3.5 divided by 1.5, and that equals 2 1/3. That's, I don't know how to eat a third of a lollipop. That's kind of gross. I'd have to like lick it and pass it on, but still 2 1/3 is a lot more than 1. So that's the range in this case. Pretty interesting. You could apply this in all sorts of different context questions like this one about surface area. And let's do that for practice.